In this trig substitution problem, there is a constant in front of the x squared. So according to the methodology, you see a square root of a squared minus x squared, right? But if you take a look at the green square root, there is a squared, so the a squared is just a 3, right? But how about the 25? There is a constant in front of the x, and we do not have a letter for that. So if you see this on the test and you never watch this video, you will be stuck immediately. So how do we take care of the 25? So to take care of the 25, it is easy. Just factor out the 25. So that is equals to 0 from to 0.6 x squared. And then in the denominator, you have to do this. So watch. You factor out the 25, and then this becomes 9 minus 25 minus x squared. And then the 25, you can take that out, right? The square root of 25 is just equals to 5. So basically inside the square bracket, you have a 9 over 25. So the 9 over 25 can be written as 3 over 5 squared. So now you know that a is equals to 3 over 5. Okay, so this still match to case 1. Okay, so since that is matched to case 1, then x is equals to a times sine of theta. So a is 3 over 5, then sine of theta is sine of theta. And then you have to rewrite change the dx to d theta, right? Then you have to differentiate. So dx is equals to 3 over 5 cosine of theta d theta. And this d theta is going to go right there. So the dx, now we change the dx to d theta. What about x squared? So x squared is equals to 9 over 25, and then sine square of theta, right? What about the square root? So the square root, you have 9 over 25 minus x squared. That is the square root of 9 over 25. I keep writing 35 minus x squared. X squared is 9 over 25, and then sine square of theta. And then you can factor out 9 over 25. I keep writing 35, huh? 1 minus sine square theta, so that is equals to 9 over 25 cosine square theta. Take the square root of that, you have 3 divided by 5, and then cosine of theta. So we just rewrite every single component, but we have to deal with the upper limit and lower limit as well, because this is a definite integral. So we have x equals to 6.6. What do we do with that? So x is equals to 0.6, then you have to put the 0.6 right over there. Okay, so you have 0.6 is equals to 3 over 5 times sine of theta, and then if you multiply 5 over 3 on both sides, then you have 1 divided by sine of theta. 1 divided by sine of theta, and then 1 divided by sine of theta. So take a look at this. According to this, the domain of theta. So when I talk about the methodology for definite integral, there is a domain for the theta, right? So this is between negative pi over 2 and positive pi over 2. So go back to the unit circle you study in trigonometry. That is quadrant 1 and quadrant 4. So between quadrant 1 and quadrant 4, how do you get y equals to 1? The answer is theta is equals to pi over 2. This pi over 2 is not the pi over 2 in the domain. This pi over 2 is you are trying to solve for theta. So theta is equals to pi over 2. What about x equals to 0? So when x is equals to 0, 0 is equals to 3 over 5 sine of theta, then 0 is equals to sine of theta between quadrant 1 and quadrant 4. How do you get y equals to 0? That is on the x-axis, right? So that tells me theta has to be equal to 0. So when you write the integral, you have theta from pi over 2, and then theta equals to 0. And then you have the integral of that. So the top, what was the top? The top was x squared, right? So the x squared is now 9 over 25 sine square theta. The square root is now 3 over 5 cosine of theta. And then the dx is now 3 over 5 times cosine of theta d theta. yes, there is a very obvious cancellation. You can get rid of the 3/5 and the cosine of theta. So let's get rid of this, and then let's get rid of this. And then do you see that I missed something that is extremely important? What was that? Do you see that? I missed something that is going to mess up the entire problem. What I missed is here. So let me do this in a different color. So let's do this in red. Do you see that there is a square root of 25? Just go back to what you wrote at the beginning. The square root of 25 is equals to 5, and it is in the denominator. Oh, by the way, I forgot a dx in here, but that is not a big deal. Right? So there is a 1/5 in the denominator. So put that 1/5 right here in the denominator. Okay? And then, let's see. Okay, we have to factor out the 5. We can factor out the 9/25 as well. So 5 times 5, 25 times 5 is 125. 9 on top, from 0 to pi/2, you have sine square theta. So this one, the sine square theta, you can use the double angle formula. So the double angle formula, the double angle formula, how about this? Maybe I should put it in this way. So the double angle formula that I am about to use came from a cosine. I will do that in a different color for you. That is came from a cosine. So let's put that in a different color. So that is came from cosine of 2 theta. There are 3. We are going to use 1. 1 minus 2 times sine square theta. If you isolate the sine square on one side, then you have sine square theta equals to 1 divided by 1 minus cosine of 2 theta. So in a when you deal with trigonometric substitution, make sure you write down the double angle formula for you. So double angle formula for sine and cosine, and there is 1 for tangent. Right? Make sure you have that prepared right next to you for you, because you have to use that almost in every single problem. Okay, so back to my integral. I have to rewrite that as 1/2, right? Okay, so let's do the 1/2, and then 1 minus cosine of 2 theta. I think that's it. You don't have to apply the formula anymore. And then you multiply. So this is 9/250. And then we can just integrate right now. The integral of 1 is equals to theta. The integral of cosine is equals to sine. But there is a 2, then you have to prepare a 1/2 in front of it. Because if you do the derivative, by chain rule, the derivative of 2 theta is equals to 2. That's why you need a 1/2 in front of it. People forget that all the time. If you only consider the integral of cosine of 2 theta, try the U substitution, and you will also see why there is a 1/2 in front. So next step, we do the FTC, fundamental theorem of calculus, plug in the pi/2. So we have a pi/2 minus 1/2, and then this is a pi minus 9/250. Once you plug in 0, the whole thing is just a 0, but we write that out anyway. Oh, 0, not theta. So this is a 0. And then sine of pi is equals to 0. So sine of pi is equals to 0. Then you have to just double up the 250. Then this will be 9 pi divided by 500. Then so this is the final answer. We did all the works for 9 pi over 500. Okay, so that is the end of this problem and this video. If you think I picked the best problem for discussion, let me know in the comment below. Like, share, and subscribe to my channel. See you all in the next one. Signing off for now.